Welcome. It is Tuesday, September 8th, and today we are going to wrap up linear equations and do some work with using solving applications where linear equations can be used to model the data. So let's take a look at what that is. When you go to your, if you're using the link that has OneNote, all right, so this would be 3.2C, modeling. And when you click on that, there's also a copy of the assignment on there. All right, first thing we're gonna do is we're gonna use our graphing display calculator. That's what a GDC is. It's just your TI 84CE that's installed on your laptops. You can also use Desmos to find the intersection. Whichever one you want to use is fine. All right, I'm going to show you today on the TI-84. Okay, the first slide here, I just put together a review or like a summary of the different forms of a linear equation that we did. And then how to find the intercepts down here, how to get your slope, parallel, perpendicular lines, okay, right there. So that's kind of everything that we've done up to this point. All right, so we're going to start with a real simple example here. All right, so using your calculators, we are going to find the intersection of these two equations, okay? All right, so the first, you're going to open up on the bottom of your calculator, or bottom of your page, you can get to the different apps that you have, and you're going to open up your TI-84CE. Okay. And then we're just going to go through and I'll just demonstrate the keystrokes as we're working on this. All righty. Okay, so it says use your graphing display calculator to find the intersection of these two pairs of lines. All right. So the first thing we're going to do is enter these two equations. So the F1 key is all the way up here. It says y equals on it. That's the key you're really looking for. And now we're just going to type in those two equations. So negative 3x plus 1. Okay, and then I'm going to use my down arrow or enter. And that takes me to the next one. And that's going to be negative 5x plus 3, enter. Okay, now to graph this, we're going to go over to the key that says graph. Okay, and press that, and it shows us our two graphs. Okay, and it color codes them for us. All right, the blue is the negative 3x plus 1, and the red is the negative 5x. All right, now the calculator will tell you exactly where they cross by using the intersect command. Okay, so our intersect command right here, I go second, and I go up to the key that says calculate. Okay, it's kind of small right here, but it's right above the trace. Okay, see it, calculate. And I'm going to choose number 5. Okay, now it's going to say that the calculator shows a cross on one of the lines and the words first curve. So if you had more than two curves, you could identify which two curves you want to find the intersection of. But I only have two curves, so I'm just going to here hit enter. Okay, I'm going to choose the blue curve, and I'm going to choose the red curve. The guess, you can move the arrow down to where you think it is, the intersection, and then press enter. And there's your intersection, 1, -2. Okay, now the ones that we'll be doing won't come out to be perfect, nice integers like that. They'll be, but you'll have to round them, okay? All right, so let's take a look at the next one here. So really, this is just practice using this. So let's clear these keystrokes. And I'm going to go y equals, and I'm going to clear everything out of here. All right, and I'm going to type in those two values. So 1 divided by 2, x minus 2, and then 3x plus 2, graph. Okay, second, calculate. Number 5, first curve, yep, it's blinking on the two curves that I want. And then on the guess, you don't really have to move it. I can just hit enter a third time. And there's my intersection. -1.6 and -2.8. All right, now the next one, it gives you, the decimals are a lot more, they're longer, and the default is in IB that will round it to 2 or 3 significant figures. All right, so let's clear everything out of here and put those two guys in. All right, on B, to enter it, if the equation isn't solved for y, you have to solve it for y. So on my second equation up here, so on the second equation, it was y minus 1 5/10, so I had to move the 1 5/10 over so that it was solved for y, and then I type it in. Okay, then we graph it. Okay, and now go second, calculate. Number 5, first curve, enter. Second curve, enter. And then there's our intersection. So if we're rounding that to 3 significant figures, all right, and it all depends on, like if you're doing it on Math Excel, it's going to tell you how many places, but our x coordinate here would round to 2, 6, 1, 5. So the 5 would tell me 2, 6, 2. And then my y coordinate, 0.8723, and the 3 says leave the 2 alone, so 0.872. And that's using your calculator to find the intersection. Okay, here's a situation where we can use linear equations to find the solution. So the following equations give a weekly salary of an employee can earn at 2 different sales jobs, where A is the amount of sales in euros and Y is the weekly salary. All right, so what you're looking at here is, for example, on plan A, your base salary is 200 euros. Then you're earning 16% commission on the amount of your sales. The second plan is your base salary is 300. So if you don't have any sales, you're going to get at least 300 euros. Then if you take the amount that you sell and multiply it by 10%, so this is a 10% commission. And we want to find, well, when are these two weekly salaries the same? Okay, so we're going to put those into our calculator and find the intersection. All right, now before I hit graph, I got to think about the window in which I can see this graph. All right, because when you hit graph, it puts it on a grid that is 10 by 10. And when we look at these formulas here, I know that my I got a y-intercept of a 200, and I've got a y-intercept of 300. Okay, so that kind of gives me an idea of what my y-axis is going to be. Okay, so to set the window so that you can see it, all right, clear that. I'm going to go, I press window, and I don't need any of the other quadrants. I just need quadrant 1 because I can't have negative sales. So I'm going to make that X minimum 0. Okay, now this is the number of sales. Okay, and so, this could be thousands of dollars, tens of thousands of dollars. Okay, I probably really don't have an idea yet until I'll graph it, but let's just say we go up to 10,000. Okay, now what I'm going to do is whatever I have this, I usually divide it by 10, should be 10,000. Okay, so each tick is the X scale. So if I divide that by 10, each tick is going to represent 1,000. Okay, now on my y-axis, y minimum is 300, or excuse me, 0, and I know that I'm going to have these 200, 300, so I might as well use the same scale here. I could go 1,000 or 10,000. We can always come back and change this. And we're going to count by 1,000. Okay, now I'm going to graph it. Okay, now if I want to get a little bit more detail in my graph, I can make those numbers smaller. Okay, so I'm going to do that. I'm going to, instead of going out to 10,000, I'm going to go out to 5,000. So I'm going to clear that. And if I divide that by 10, each tick is 500. 5,000, each tick 500. And let's see if we get a little bit more detail. Not too much. So if you're looking at these amounts right now, way out here to the right, that X value, that's only 1,000 right there. So I can really reduce these numbers. I'm going to go now to 1,000. Divide that by 10, that's 100. And do the same thing for this guy. 1,000 divide by 100. Now let's take a look at it. Yeah, we got a little bit more. Oh, but now we can't see where they cross. Okay, so we need to go further to the right. So I could zoom out, or I could just change my window. Let me show you the zoom out. Okay, so I'm going to hit enter. Now I'm going to put my cursor where I want to zoom out. So I'm going to go all the way over here to the right. And then I'm going to hit enter. Okay, and now I can probably do my intersection. Okay, now you can keep playing with the window if you want. So 1,000 is way too high. on the y-axis here. So let's go back here and change that to 0. And maybe make this, I don't know, 500. Count by 50s. Make that 0. And this one, maybe go, I think we had to go out further, so we'll go out to, say, 3,000. Count by 300. There we go. That's not too bad. And now we can see it better. So sometimes it's just a matter of playing around with the scale. Then we go second, calc, 5, 1, 2, 3. There we go. And there's our intersection. Okay. So now we have an idea of where these two things cross. And what the intersection is. Okay, right there. And that was $1,666.67. That's the sales. And then the salary is $466.67. Okay, so that's my salary there. And this is my sales. Okay, and now on these two deals, let's see. The blue one was the 10 or the 16%, and the red one is the 10%. Okay, so let's see. The red one, this is your y equals 10%. Oh, that's terrible. Let's clean that up. Can't read it. Okay, and then the blue graph was the top one. Plus 200. Okay. And then here's where they are the same. Okay. So the blue formula, which is this one, that is this one. So depending on what your sales are, if you're not selling a whole lot, then the red is a better deal, up to sales of about $1,600, $1,700, because it's above the blue. Once you pass that point, then the first deal is better because its graph is above the red one. So it really depends on how good of a salesman you are. If you're a better salesperson, then A is the better salary structure. If you're not such a good salesperson or the people aren't buying whatever you're selling, then B would be a better sales structure. So then to answer the question, what's the sales amount? $1,666.67 is where they're both the same. A classic example of the use of linear functions to model data is converting between Fahrenheit and Celsius. Okay, so we have this chart that shows us the different equivalent degrees for Celsius and Fahrenheit. All right, it says find a linear model that relates the temperature Fahrenheit F in degrees Fahrenheit to the temperature C in degrees Celsius. Give your answer in the form F of C equals MC. Okay, so C is Celsius. So what this is going to be is we're going to do Fahrenheit in terms of Celsius. So Fahrenheit is going to be our y coordinate. So our function f of c tells us that Fahrenheit is going to be on our y-axis and Celsius is going to be on our x-axis. Okay, so we can take this data here, pick 2 points, and create an equation to model Fahrenheit or Celsius into Fahrenheit. All right, so I'm going to take, for example, 0.32, and I'll take the other high point, or that's the low, and I'll take the highest one. And I'm going to just treat those as 2 points. So I've got 0.32, and I've got 35.95, and I'm going to use my point slope form or point gradient form to get the equation of this. Okay, so we got to get our slope. So I got my slope here, 9/5, and then I choose one of these 2 points. Well, I think I'm going to use the one with the 0 in it and substitute into my formula. So I got y minus, y2 is 32, 9/5, x minus 0. And then if I simplify this, I get my conversion, my linear equation, 9/5 x plus 32. Now remember, the x is the Celsius and the y is the Fahrenheit. So it would actually probably be F equals 9/5 C plus 32. In function notation, f of c equals 9/5 c plus 32. Okay, now use your model to convert 27 degrees. That's just plug it in. So Fahrenheit is equal to 9/5 times 27 plus 32. And we end up with, when we multiply that out and add 32, we get 80.6 degrees Fahrenheit. Okay, use the model to explain whether an increase in 1 degree Fahrenheit or an increase in 1 degree Celsius is a greater change in temperature. Well, what you want to do is find the slopes and compare them. All right, we've already done one of them. Okay, so our first example here is when we can get Fahrenheit by taking the Celsius and multiplying it by 9/5. Okay, that's the increase. So for every degree C increases, okay, this is our slope here. Okay, so look, I guess I should write it like this. If we did 9/5, all right, if I divide that out, I'm going to get 1.8. 9 divided by 5. Okay. All right. Now, what that means, that's the slope. So, when C increases by 1, Okay, F increases by 1.8. That's what the, okay, now we'll do the slope where we switch those two. Okay, so remember this 1.8 was from this formula up here. That's how we got then the 1.8. So all I'm going to do is take these two coordinates, sets of coordinates, and reverse them. Okay, so my other slope is going to be, I'm going to have, instead of 0.32, I'm going to use 32.0. That's F, that's C. Remember earlier, the 0, this was C, and that was F. Okay, now I just reversed them, and then 95, 35, right? Yep. Okay, and now do my slope, and what do you think is going to happen? Okay, so I got 35, take away 0, over 95, take away 32. See, it's just the reciprocal slope. So this is going to be 5 over 9. Okay, which is around point, when I round it, 5, 6. Okay, so now what that means, F is the x-coordinate or the dependent variable. So when F increases by 1 degree, C increases by a little over half a degree. So you can see that you get a bigger increase. 1 degree Celsius, 1 degree increase in Celsius creates a bigger change than 1 degree increase in Fahrenheit. All right, find the value in which the temperatures are equal. Okay, so we're gonna put in these two. We're gonna put in an equation for each one of these and see where they cross. All right, so let's do that. This would be D. Okay, so to get my other equation, it's the inverse. So I switched X and Y. And now I'm going to solve for Y. Okay, so once I've done that, I'll end up with Y equals, and I get my other equation, 5/9 times the quantity, X minus 32, is equal to Y. Okay, so this formula here converts Fahrenheit into Celsius, and the one up that I did earlier is Celsius into Fahrenheit. Okay, so I put both those in my calculator, and we'll graph it. And when you graph this, your original graph won't look like that. You won't see anything. So when you just hit graph, you'll see that. Okay, so what I'm going to do is just zoom out. So I go zoom, and I choose number 3 out. And now you put the cursor where you want to zoom out from. We're just going to zoom out from the origin. And I can see my graphs now. Okay, so I'm going to hit second, calculate, and number 5, intersect. First graph, second curve, guess, and there's my intersection. All right, so what that tells me is when x is negative 40, okay, so negative 40 degrees Celsius is the same as negative 40 degrees Fahrenheit. That's when the two temperatures are the same. All right, the assignment for this is Math Excel 18. You'll need your graphing calculator or Desmos, either one, and solve applications that are modeled using linear models. And this is, let's see, this is Tuesday, so this is due Thursday. All right, folks, that's it. Everything's fine over here, and I'll see you next time. Take care.